flight delay arrival time. The flight delay arrival time in minutes are recorded below. My question is, do the data indicates or proves that airport A has higher delay arrival time? The significant level is 1%. So we have two airports, airport A and airport B. And then in airport A, I have 14 samples, and then the average delay time is 20 minutes. The standard deviation is 8 minutes. And then in airport B, my sample size is 10. Average delay time 17 minutes, and then the standard deviation is 9 minutes. How do you know this is a two sample t-test? The question is, the answer is you don't know the population standard deviation, right? So since you have unknown sigma, then this is a t-test. Okay, but how about a two sample t-test? How come this is not a match pair test? The reason is we have two independent samples. So we have two independent samples. So therefore, this is a two sample t-test. All right. And then how about the alternative hypothesis and null hypothesis? The question is, we want to prove that A has a higher delay time. Okay, so A is higher than B. So this is what we are trying to prove. That means we are trying to prove A is greater than B, right? So we are trying to prove that A is greater than B. So the greater than goes to the alternative hypothesis. So if I change the word to reject, then the greater than goes to null hypothesis. So since this is a proof, we are trying to prove that the alternative hypothesis is true. So that means HA is mu1 is greater than mu2, or you can write mu A is greater than mu B. And then your H naught, the problem didn't give me a sign, so I will just take the opposite. Mu1 is less than or equal to mu2. All right, and then the next step is, so you follow the screenshot, we will input all the stats to our graphing calculator. So we go to stat, and then we go to test. So we hit the stat key, and then you find test, and then we are performing a two sample t-test. So we select a two sam t-test, and then since we don't have data, we select the stats option, and then the stats option, you will input the stats, right? So x1 bar is 20, s1 is 8, and then 14, and then 17, 9, and 10. And then very important, which inequality sign do we choose? So since we are trying to prove A is greater than B, then we will choose the greater than. So mu1 is greater than mu2, and then the pole is no in this problem. Under when do we select a yes for pole? The answer is when the problem has a very clear statement saying that they assume the population variances or standard deviation are equal. One more time, you select yes for pole when the question has this sentence. We assume the population variances or standard deviations are equal. They assume they are equal. You don't have to know what it is. As long as they assume they are equal, then you select yes. All right. So since this is a no, then the formula for a not pole is T equals to x1 bar minus x2 bar, and then parenthesis mu1 minus mu2. Some textbook they don't write mu1 minus mu2 is because in the H naught they assume they are equal. So since they are equal, then mu1 minus mu2 is equals to 0. Two identical numbers subtracting each other will just give you a 0. And then divided by the square root of s1 squared divided by n1 plus s2 squared divided by n2. So we take this from our calculator, and then we also have to report the p-value, and also we have to report the degree of freedom. Okay, so once everything is ready, you hit calculate, you will get the p-values. If you hit a graph, you will get this. So sometimes you might be asked to draw this on your paper. So since this is a greater than is a right-sided test. So since this is a greater than, we have a right-sided test. That means the p-value is on the region, the red region is on the right-hand side of the curve, and then the cut is where the t-value is, or the test statistic is. So you have t equals to 0.8428. So let's see on my calculator. Once I hit calculate, so I get a t, the test statistic. For myself, I usually keep that in 3 decimal places. So I will write 0.843. 0.843. But if you are doing homework online or on paper, your instructor want you to give 4 decimal places, then you write 8428. Okay, and then the p-value, I like 4 decimal places, so that is approximately equals to 0.2052. So this is a big p-value greater than 1%, so greater than alpha. That means we have the fail to reject H0. And then the degree of freedom, has a pretty big formula. I never asked students to write that formula out. I asked them to take it straight from the calculator, which is approximately 18.05. The number of decimal places, please read the problem. All right. Okay, what's the conclusion? The conclusion is we fail to reject H0, right? So this one is we fail to reject H0. Why? Because p-value is greater than alpha. So since p-value is greater than alpha, we fail to reject H0. And then what do we say? We fail to reject H0. That means we cannot prove HA is true. So cannot prove HA is true. So that means we cannot prove airport A has higher delay arrival time. So airport A has higher delay arrival time. And then this is the end of the 2-sample t-test. So here is the procedure. First, we decide what test do we use, and then we state the H0 and HA, and then we calculate the t, the p-value, and the degree of freedom, and then we state a conclusion. And then this is the end of the 2-sample t-test. And then the next stage is doing a confidence interval. So for confidence interval, since alpha is 1%, right? So we have a 1% alpha, then we have to construct a 99% confidence interval. The formula is we have a point estimate x1 bar minus x2 bar, and then plus or minus t alpha divided by 2, degree of freedom, and then square root s1 squared divided by n1 plus s2 squared divided by n2. And then we take the number straight from our calculator. So we have to go to stat. So we go to stat, and then we go to 2-sample t interval. So 2-sample t interval, we have stats. So make sure these numbers, if you're using your TI-84, you don't have to change any numbers. But the calculator I'm using right now is not exactly a TI-84, so I have to do some changes right here. So really quick, so x1 bar is 20, and then we have a 8 for S1, and then N1 is 14. And then x2 bar, we have a 17, and then S2 is 9, and then N2 is 10. So clean that 10, and then 0.99. So once everything is done, and then you hit calculate. So let's hit calculate. So hit calculate. Since this is a fail to reject, then the confidence interval will be 1 negative and 1 positive. So we have a negative 7.243, and then positive 13.243. Now, using the p-value, okay, we make a conclusion. The conclusion is fail to reject H0. Can you use this confidence interval to support your conclusion? Here is how you do it. I call this verification. Verify. So here is how you verify. First, you state your H0 again. So your H0 is mu1 minus mu2, and then you do a little math. That means mu1 minus mu2 is less than, okay, here, mu1 is less than or equal to mu2. So that means mu1 minus mu2 is less than or equal to 0. One quick example, 1 is less than or equal to 9. That means 1 minus 9 is less than or equal to 0. Just that's how it works. Now, look at this less than or equal to 0. So equal to 0 means a 0, right? Less than 0 means you have negative. Now, 0 and negative. Do we have such kind of number between inside the confidence interval? Once again, the confidence interval says the truth is between negative 7 and positive 13. And then when you verify, you recall your H naught. That means you are saying that the less than or equal to 0 is the truth. Now, do a check for me. Is this between -7 and +13? The answer is yes. 0 and negative values, they are between -7 and 13. That means the H naught can be the truth, right? So here is how I do it. I will just call the less than or equal to inside the confidence interval. So this is inside the confidence interval. That means this might be the truth, right? So that means H naught can be true. So therefore, we fail to reject H naught. So we fail to reject H naught. Do you see that? We fail to reject H naught using the p-value, and we fail to reject H naught using confidence interval. So this is called using the confidence interval to verify or to support your conclusion. And then one other thing that we can say is we can explain what those two numbers mean, the -7 and 13. So they are obviously, the unit is obviously in minute, right? So it's -7 minute and 13 minute. What does that mean? Can you explain those two numbers to me? So here is how we do the explanation. So we are trying to explain. So explain the confidence interval. The language are different. So here is how we explain that. I'm going to say we are 99% confident. So we are 99% confident that the average difference of delay time between both airports falls between I will just round a little bit, -7.2 and +13.2 minutes. Okay, to be honest with you, when you have a negative and a positive, that doesn't make any sense. So here is why. So let me give you a quick explanation. So let's say I use a number. So let's say I'm using a number 5 minus a 12. So 5 minus 12, this is negative, right? So if you have a confidence interval that has negative and positives, so here is what that means. I have a number and then another number, unknown 1 and unknown 2. I am saying that I'm giving you 3 hints. Number one is they are equal. Number 2 is 1 is greater than 2. Number 3 is 1 is less than 2. And I am saying that they are all true. Do you think this hint is helpful? They are all true. As long as you are saying that they are all true, those hints, they are just trash. Because when you compare two numbers like 5 and 12, 6 and 1, or 0 and 0, when you compare two numbers, either one of these is true. Only one of the hints will be true. If you are saying they are all true, that means you are telling me nothing. Right? Another way to say this is, okay, I finished a course, so here is my grade. My grade is either an A, B, C, D, or F. Is this hint helpful? No. Every time you get a grade, it's either A, B, C, D, or F. You cannot say, okay, it's either one of this. Then you are telling me nothing, right? So that is the end of this problem. If you think my instruction is helpful and clear, give me a like, share, and subscribe. I will see you all in the next one. Signing out.